Hello, hello, hello. Just checking the sound. Just checking the sound. Okay, it's okay, fine, fine. So, good evening, everyone. Good evening, everyone. And last day only, I told you that unlike to the other YouTubers, I'm not going to create those kind of jokes and all. I'll just teach it very normally, as I do usually. So you may not be getting those threshold, थोड़ा बड़ा चढ़ा के जो हल्ला करता है, that you will not get. But definitely, it's a serious study that I can say you. So we'll really go with the serious study. So anyway, welcome again, all of you, whoever are watching. I'm not also expecting many to watch. I don't need thousands of viewers. So anyway, let's have a good start with 3D today, right? So let me start with 3D without much delay because now the time is precious. So in 3D geometry, so our main concept starts with the direction cosines of a line. So let me start with those basics and go quickly to the overview of whatever we have got. Kyuki without the formula, you will not be able to understand the entire things. So I'll try to move in a quicker way to finish those concepts first, then we'll take the problems. Okay, so what do you mean by direction cosines of a line, right? So direction cosines means suppose I have this line. I have line and this line is making certain angle with the three coordinate axis in space, right? So this line I have made the three coordinate axis. This is the x axis, this is y axis, positive side I am drawing, and this is z, and this is going to be my line. So I can like anywhere this line can be, but whenever I want to find the angle, I can slide it to pass through the origin so that I can think about the angle. So this angle is alpha, that is the angle made by the line with x-axis is alpha in the positive direction. This angle is beta, and this angle is gamma. So if these are the angles, then L equal to cosine of alpha, M equal to cosine of beta, and N equal to cosine. Simply cosine you take. These are said to be direction cosines of the line. They give us the direction of the line. Now they are unique because we are considering the angle with the positive sides or positive measurement angle we are considering. But if we consider the supplement, then we will be getting negative of these values. So we don't confuse with that as different direction cosines. They are the same. Just idea is that we took the other angle. Okay. So immediately whenever we get this, we have a very important result related to this. This must be always remembered. That is L square plus M square plus N square equal to 1. This is a important result which you need to always remember. This is very, very important, which you always have to remember. Then corresponding to this, if you use exactly cos square alpha plus uh, cos square beta, cos square beta plus cos square gamma equals to 1. This is the result. And then what exactly is followed is this is seen to be a problem actually in the exam, that instead of writing cos square alpha, I can rewrite this as 1 minus sine square alpha, this as 1 minus sine square beta, and this as 1 minus sine square gamma. creating one more result for us, that is sine square alpha plus cos square, I'm sorry, sine square beta plus sine square gamma equals one of the one will be cancelled and this is 2. So I have seen there are MCQs where they are asking to find the value of this, and this can be a 2 mark question. Similar way, you can take the help of class 11 identity. I am saying you this question is there, so I'll not do it here. We can remember cos squared theta equal to half times 1 plus cos 2 theta. Now, if I use this particular identity to each of these angles, so I can really find a very nice relation between cos 2 alpha plus cos 2 gamma and plus cos 2 beta. So that is actually a question there in the subsequent slides. So I'm not proving it now. So this is very important thing about the direction ratios. I mean cosines. Now, direction, what is direction ratio? Direction ratios are also called direction numbers. So, if I consider this as this is direction cosines, then proportional to this, if I find any number, then those are known as direction ratios. Say A, B, C are such that these numbers are proportional to this direction cosines, that is ratio of a and l, b and m, and c and m, this should be always same, right? If this is the case, then we say this abc as direction ratio. Sometimes we call it direction number also. So don't get confused whenever you get the the wordings direction numbers and direction ratios. Direction ratios are only called direction numbers. And as there can be many proportional numbers to LMN, there are infinite number of direction ratios for the same line, whereas there is unique direction cosines for the line. Direction cosine and direction ratios are very fundamental things which always you should be clear. Okay. Once we are done with this, then immediately we get equations of line. Equations of line. So there are basically two types of lines. There are only two types in your syllabus. Sorry. So I just for like convenience, I am writing this as type one type, and other type I write here only. If you compare side by side, it will be easy for you to remember. Type two. In type 1, what happens? I have a point whose position vector will be known as A. I can name the point as A also, capital A. And I'll be having another vector B, right, to which this record line will be parallel. So I can draw exactly one line through this A, which is parallel to B. So in that case, equation of this line will be represented by R equals, vector R equals to A plus lambda times B, where lambda is a scalar, preferably non-zero, right? This is one. And then other one is very clear. Other one, I should get 2 points only. I do not need any extra vector. So through 2 points, you can draw exactly one line. So here the equation will be R equal to A plus lambda times B minus A. Actually, what happens? We have used the first form to deduce this. I just tell you quickly so that it will be clear. If I tell you that what is B minus A, I mean AB vector, what is AB vector? You would definitely say it is B minus A vector. There is no mistake, right? B minus A vector is actually parallel to the required line. So now we use the first form to rewrite this equation. That's the thing what we use for the deductions, right? So even if you don't understand the deductions, it will not make more difference in the entire concepts. These are in the vector format. Now I need to remember in the Cartesian format also. So this point in Cartesian format, I can write this as what? Coordinate is x1, y1, z1. And these vectors I can write in terms of its components, that is b1 I cap, b2 j cap, and b3 k cap. So after that, if I put everything here in this, okay, one more thing, let me try to tell you. Whatever variable we use in three dimensions, that are x, y, z, in vector, this is represented by the vector r. So r is nothing but x I cap plus y z cap, j cap plus z k cap. So if I put every values here, I get one equation. I just want to show you one of them. If I write this for all x component, so for r I'll write x, for a x1, lambda will be there. For b, the x component is b1. So overall, if you try to find what is a lambda, that is x minus x1 by b1. Okay, afterwards I'll modify this. I'll not write as b1. As of now, I'm writing b1. And then similarly, this lambda can be found from this y also. So it will be b2. And then z minus z1 divided by b3. This way. What I mean to say is that overall, you observe the points are coming in the numerator, and components of the vector to which this result is parallel or the line is parallel is coming down. So now what I can say is that you can remember these components of a vector are actually direction ratio of that corresponding line. So direction ratios are coming in the denominator. Similarly, if you consider these points as x1, y1, z1 and x2, y2, z2, your line equation will be x minus x1 divided by x2 minus x1. Kyunki the first component of direction ratio of the line or the vector AB is x2 minus x1. Similarly, you can write this. Now, there may be a question in your mind. Let me clarify that. Should we write x minus x1 in the numerator? What if I write x minus x2? Absolutely, there will be no problem. So if you want, you can write here x2, y2, and z2 as well. Your answer will be absolutely correct. Again, in the denominator also, if you don't write x2 minus x1, you want to write x1 minus x2, it will still do. So in a nutshell, I'm now going to sum up these two forms because very, very important they are. I got two different forms of the line. One is x minus x1. This time I'll not write b1, b2 because I want to get the symmetry of all the expressions. Y minus y1 by a, z minus z1 by c. This is one line which is passing to the point x1, y1, z1 and parallel to the vector whose components are a, b, c. And the other form of line is x2 minus x1, x minus x1 divided by x2 minus x1, y minus y1 divided by y2 minus y1, z minus z1 divided by z2 minus z1. I am taking little more time here because this is very, very important basics. So I got the line. This is in the Cartesian form and the vector form is r equal to a plus lambda b, and here the vector form is r equal to a plus lambda times vector b2 minus vector a2. Be very precise, don't omit these vector signs, right? If your other calculations will be correct, but if you omit the vector signs, you may be given a lot of negative marks. So be very, very alert about that. Okay, after doing this, immediately we talk about angle between lines. Angle between two lines. Two lines, we have to talk about the angle because we have to talk about the perpendicularity and um, parallelism conditions. So angle between the two lines are nothing but the angle between the two vectors to which they are parallel. Just say for example, if I have these two lines, if my first line is r vector equal to a plus lambda b, I mean b1, suppose a1 ऐसे लिख देते हैं, r equal to a2 plus mu b2. So you should be able to remember immediately that the first line is actually parallel to this vector b1 and second line is parallel to vector b2. Immediately you should be able to visualize this. So it's all the same to find the angle between b1 and b2, which is nothing but the angle between the lines. So if I consider this as theta, angle between these is nothing but angle between b1 and b2, and b1 and b2 vector already we got it. It is done by dot product of the vectors divided by their magnitude. And to more clarify it to be an acute angle, you put a overall modulus. So basically you find the acute angle between the two lines. It's done. So this expression can be also converted from here into its Cartesian form. How do you do it? Components of B1 and B2 are basically A, B, and C. For the other line, I'll consider this as A dash, B dash, C dash. There are two lines. So they will be A dash plus B dash plus C dash. And then below it is A square, because you are talking about the magnitude of the vectors. A square plus B square plus C square whole into root over a square, a dash square plus b dash square plus c dash square. So this is the angle expression for you. And from here only you can get the perpendicularity, which I'll not write separately. Here only I'll tell you. Perpendicularity means theta is 90 degree. Theta 90 degree means cos theta is 0. It means your numerator should be 0 for this expression. So numerator is 0 means this quantity should be 0. If this a dash plus b dash plus c dash is 0, then you can say that lines are perpendicular. And whenever you are talking about parallel lines, what will happen? Direction ratios of the parallel lines are proportional, right? So b1 and b2, these two vectors will be parallel to each other. In that case, components will be proportional. That means a by a dash equal to b by b dash equal to c by c dash. So this is the condition of parallelism. So these are enough concepts. Now two more important concepts are left out. That is the shortest distance between two lines and distance shortest distance between two parallel lines. So here one word is coming because I have seen one MCQ also. The word is skew lines. Skew lines. What are skew lines? Skew lines, I'll write in a short thing. They are in space, right? Lines which are neither parallel nor intersecting. They should not intersect, they should not be parallel. Those kind of lines are known as skew lines. So now we are going to talk about the shortest distance between skew lines. Shortest distance between skew lines. Right? Two lines are skew lines when they are neither parallel nor intersecting. So let me consider two lines, say r equal to a1 plus lambda b1. This is one line. R equal to a2 plus mu b2, another line, right? So I want to find the shortest distance. So as d say d, I want to define it. I'll write the vector expression. I'll give you how to remember this. The vector expression is a2 vector minus a1 vector cross product, dot product. Here it is dot product. Then it is b1 cross b2. This dot must be visible. And below it is magnitude of b1 cross b2. Right? This I can convert into Cartesian expression also, that also I am going to tell you. But before that, I just would like to tell you what is a memory aid to remember it. One simple sentence you remember. It is projection of a2 minus a1 vector on cross product of the vector b1 and b2. So you try to remember the projection formula for vector, right? Then you can easily remember this without any hassle. You will never commit any mistake, right? So now I want to write its Cartesian equivalent also. That is also equally needed. So the first line I would like to convert into Cartesian equation as x minus x1 by a, y minus y1 by b, z minus z1 by c. The second line in Cartesian form, I would like to write it as x minus x2 divided by a dash, y minus y2 divided by b dash, z minus z2 divided by c dash. So what is the distance here? Just try to remember. I don't want to write. Okay, let me write the determinant only. I can directly write the expression also, but it may be a little difficult to remember. Let me write the determinant. So how you will remember what determinant will be written? Just you listen to me that carefully. You will never forget. First of all, you just see the second component and third component. I mean, whenever you are finding the cross product, try to remember whenever you have found the cross product of two vectors, the first row is I cap, j cap, k cap. Second row is component of the first vector. Third row is component of the second vector. So here you can see the cross product. So the first vector's component will be coming in the second row, that is a, b and c. Second vector's component will come in the third row, that is a dash, b dash, c dash. And in place of ijk, you put the components of this. So this will be x2 minus x1, y2 minus y1, and z2 minus z1. Right? This is done. How this is x2 minus x1? Easily you can remember because these are points, right? So you have to subtract these corresponding coordinates. And below, to write below what is b1 cross b2 magnitude, really take no tension at all. Once you write it, you apply the cross multiplication method. How? Just see it. You can pick any two consecutive numbers and just write it like this. Suppose the first two pair. A you multiply with B dash, then simply exchange the dash. A dash B. Then you start with the alphabetical order. B C dash, then B C, B dash C. And last one will be the reverse, of course. Because see, B C dash will go there. So next will be what? You can think about writing A dash here once. I am writing, you don't have to write. You'll be able to remember. So this will be what? C A dash minus C dash A whole square. So this is the formula. And overall, there should be a modulus sign because distance will never be negative. So this is very, very important thing. This is the shortest distance formula of two skew lines. Right? Now the last conceptual thing, after that we can start with the problems. That is the distance between two parallel lines. This is little critical, I'll not say, but students sometimes miss it. Okay. So, okay. Distance between two parallel lines. Distance between two parallel lines. How would parallel lines be identified? Just see it. Parallel line would be identified by looking at the vector to which it is parallel. Right? This particular part must be same. This B must be same. It should not be B1, B2. If you find that they are same, it means the vectors are parallel. In that case, the shortest distance or simply the distance can be found by this formula a2 minus a1. And then earlier you had b1 cross b2, but this time both the b's are same. So it will not be b cross b. It will be otherwise giving you zero vector. That cross will be coming here and b vector will be remaining. And below it's the magnitude of this b vector. So that's the formula, and overall this is the theory part for our entire class 12 syllabus. So now let's start with the problems. We are now going for the problem solving. Let me try to make it comfortable for you. You need not really write the problems because I'll share the entire this notes in your class group. So let us just try to see, and if it is possible, try to identify the answer from your side as well. And whatever necessary concept what I did not explain there, now I'll explain with the problems. Okay, this is the first MCQ problem. The equation of a line parallel to the vector this passing through the point this is. They did not write the line in the form what we expected, right? So first of all, I'll explain the background and then at last I'll tell you the shortcut because background is to be known. So how would you write this equation? Passing through this point and parallel to this. So Cartesian equation, if you write, your equation will be x minus 4 divided by the component 3. Then y minus minus 3, that is y plus 3 divided by the component 1, and z minus 7 divided by component 2. Actually, what is the shortcut? You can directly do it. But anyway, now you equate it to lambda, or here you can see the parameter is given to be t. So you can write this as t as well. So let me write it as lambda only. So in that case, each fraction you equate to lambda. This if we equate to lambda, what you will get? I am doing it very extensively so that you can understand it. So from here, x minus 4 equal to 3 lambda. So your answer is x will be equal to 4 plus 3 lambda. So it will be 3t, right? So let me see whether there are more or one of the expression. Then I can easily see the answer from here itself. So it is 4 plus 3 lambda. That is 4 plus 3t. There are three options. First option is ruled out. Fine. Now let me go for the second one. Can you write the second one directly now? That is a shortcut I'm talking about. So it is y equal to lambda minus 3. That is in my case it will be t minus 3. So second will be ruled out because it is t plus 3, right? This will be also ruled out. I have to go for this, right? For your confidence, try to verify the last one also. So z will be equal to what? 2 lambda plus 7, that is 2t plus 7. So this is the answer. Actually these are said to be this parametric form of the point on the line, right? If I talk about a line, point on this line, it will be found like this. Okay, now let me go for the next question. The angle between angle which this line makes with the positive direction of y-axis. Positive direction of y-axis. Okay, now you see whatever we get in the denominator. Whenever I write the line in this form, this is known as symmetric form. Then the denominators are either direction ratios or direction cosines. So you first check whether they are direction ratios or direction cosines. So my numbers are 1, -1 and 0. They are not forming the direction cosines. Why? Because if I add them up, I get 2, right? I get 2 by squaring, adding them, I get 2. That means it should be 1 to in order to get this as a direction cosine. So first you make it direction cosine. How do you make it? मैं थोड़ा सा यहाँ बोल देता हूँ. जैसे if you have ABC as the direction ratios, the corresponding direction cosines are just you have to divide by square root of this a square, b square, c square इनका साम से. So here I should divide by square root of this. Now I made them as direction cosine. I made them as direction cosine. So this is the direction cosine which is related to the angle made with y-axis. So actually this is nothing but cos of beta. Cos of beta is -1 by root 2. So -1 by root 2 is in the second quadrant, right? So your angle, can you recall cos of 1 by root 2 means for 45 degree? And because it is in the second quadrant, it will be what? 180 minus 45 degree. That is giving you 135 degree, right? but of course it is given in pi, so it is better at the beginning only you write pi minus pi by 4. So your answer is 3 pi by 4. 3 pi by 4. So this is your answer. Answer is B. Move on to the next. Cartesian equation of the line passing through this point and parallel to this line. Right? It's a very easy equation. Just how would you think about? You try to convert this into a plus lambda b format, and then you take b from here for writing the direction ratios. So immediately in the same step, how you can write it? So you write here all those which are not related to lambda, and here you write all those which are related to lambda. As it is MCQ, I don't really bother about this. I'll write only the quantities which are related to lambda. The first one will be I cap. Second one you can see it is j cap, and third one you can see it is 2k cap. So this is my vector ready. Now check the points. X minus 1 should be there. So it is rejected. It is rejected, right? So this may be possible. This may be possible. So at the same time, you check this value. Here it is 1, but here it is 2. So this is rejected. That means this is the only answer correct, right? So rest you need not check only because there is no more options left. Had there been none of this, then it would have been a problem. So here, but still, once for our own convenience, you can check it. So y plus 3 divided by 1, okay. Then z minus 2 divided by 2. So that is the answer. So don't waste much time. Here you see I am explaining, but still I can solve this problem below 1 minute time. You can also do it. Okay. A vector perpendicular to this line is acha. Suppose this is the line, right? I know that this line is parallel to one vector. What is that vector? That vector is 3 I cap minus j cap. Then they are saying out of these four lines, one line is perpendicular to this line. So if my required line is perpendicular to given line, this line also has to be perpendicular to this line. So you just check out of these four vectors which is perpendicular to 3ij, 3I minus j. So how do you check the perpendicularity of two vectors? Simply dot product should be 0. So you just check with whom the dot product is 0. So I think D will be the answer. Let me just try to see. No, not D. Mm, yeah, this can be answer. B. Let me just try to see. 3 into 1, this is 3. Minus 1 into 3, minus 3. There is no k component. So this is 0. So this gives you 0. So dot product is 0 for this vector and this vector. So they are to be perpendicular. Right? I hope it is clear to you. Okay, the lines these and these are perpendicular. You have to find the value of P. So you have to now apply the conditions. But before that, there is a trick always for this kind of problem. Be very, very alert here. What is the trick? The trick is that they may not give you the line in the standard form. So here also it is not in the standard form. You check it, please. 1 minus x is not in the standard form. It should be x minus 1. So let me put them in the standard form first. So it will be x minus 1. So there will be a change of sign in the denominator. Fine. Then y minus 1. This is 3. Z minus 0, this is 1. Fine, my standard form is coming. Here I should write this also in the standard form. It should not be twice x minus 3. It should be x minus something. So I have to divide by 2. So it is x minus 3 by 2 divided by p. Then y minus 0 divided by minus 1. And then z minus 4 divided by 7. Now, whenever these lines are perpendicular, what happens? You can remember, you make it a habit. A dash plus B dash plus C dash equal to 0. So minus 2p plus this product, that is minus 3, plus this product, that is 7, is 0. So minus 2p is equal to, it will be plus 4. So minus 4. So what is p equals? My handwriting is very bad, but still I think it will be understandable. P equal to 2. So your value is this. So you can do it very easily. But only thing is that be very alert. They may not give you these things in the standard form. Be very, very alert about this particular part. One mistake I did. What mistake I did? It should be P by 2. Sorry. P by 2. So it will not be P. It is 4, 4. Where did I do the mistake? I have made a mistake. I think 3 by 2, 3 by 2. Oh, it's okay. It's okay. Sorry. Earlier only I was correct. It's okay. I made it. It is 2P, so it becomes P. Okay, fine. Next. This is the question I was talking about when I was explaining you the direction angles. Alpha, beta, gamma are the angles which a line makes with positive direction of x, y, z axis. Then which of the following is not true? Remember, is not true. This is true because this is the original one. It is also true. We have already verified, right? This will be also true. You check that, right? Let me check only, right? So my original result, this is true now. So what I can write here is half into 1 plus cos twice alpha, then half into 1 plus cos twice beta, and half into 1 plus cos twice gamma. This will be equal to 1. So easily you can identify this half can be multiplied. That side it is 2, and there are addition of 1 3 times. So 3, 2 minus 3 will give you minus 1, and left side you will be left out with the sum. So this is also true. This will not be true. So your answer is this. So you can get it very quickly once you remember the result. Cartesian equation of the line passing through the point with position vector this and parallel to this vector. So this is, you can directly do it. Passing through this point means for x, it is x minus 1 and then y plus 1 passing through this point. So you check x minus 1 and y plus 1 kahan hai. X minus 1 is here. It is not possible directly because it is passing through this, right? X minus 1 होना चाहिए, ये नहीं होगा. This can be any one of this can be, and then next you go for x minus 1, then the next component will have numerator y plus 1, x minus 1, then y plus 1. So this is rejected. Your answer is this. So you need not do more about this, right? So you got it even within less than 1 minute. The angle between two lines, this is again angle cos theta. You have to find, you have to identify what is A, what is B, what is C, and what is A dash, B dash, and C dash. So here directly now you can do it. A is what? 2, and A dash is what? It is 1, right? Then B dash, B is what? See, it is reverse. So you reverse it, swap it, then it will be 5. Then what is B dash? B dash is 2. Then C is 4, and what is C dash? C dash is minus 3. These things in the numerator, and then sum of the squares of these numbers below. So say 2 square, in the same go you do it because it is MCQ. 2 square means 4, 5 square means 25, 25 plus 4 29, 29 plus 4 16, 29 plus 16 means this is 5, it is 45, right? Then square of this 1 plus 4, 1 plus 4 is 5, 5 plus 9 is 14, right? So you got this. Now 950, is it 14 or 9? Then 9 plus 4, 9 plus 4 will make it 13, 13 plus 1 14, then 25, 25 plus 16, 25 plus 15 would be 40, 41, 41 plus 4. What did I do the mistake? 25 plus 16, 25 plus 4 29, then 16, 25 plus 16. Okay, right. 45. So now you try to see what will be the result. 2, 2 plus 10, 12, 12 minus 12, 12 minus 12, 0. So you need not work out this really. So cos theta is 0. Cos theta is 0 at what? 90 degree. Done. Okay. Cartesian equation of this line. Okay, this is interesting because these kind of questions are not there in the textbook directly. So this is the question which you need to know how to tackle it. So Cartesian equations of this line is given by these three. It doesn't seem like that x minus 1 type. No problem. So 6x minus 2 is equal to 3y plus 1 is equal to 2z minus 2. So whatever is there in the denominator, that is actually 1. Now make it in the standard form by dividing by 6. So it will be x minus 2 by 6, that is 1 by 3. So it is 1 by 6. Then by 3 you divide y, 1 by 3 divided by 1 by 3. Fine. Then z minus 1, it will be 1 by 2. So now they are asking you the direction ratios. You got the direction ratios as 1 by 6, 1 by 3, and 1 by 2. None of these are matching with this, right? You may be in a fix. But actually, this is a trick because direction ratios are proportional. You make them integers by proper multipliers. I don't want to write the numerators. I'm not concerned about that. So you take the LCM of this by 6 you multiply. So if you multiply by 6, this will be 1, this will be 2, this will be 3. So your direction ratios are this. Hence you are done. Right? So this is one set of direction ratios. Done. Direction ratios of the vector parallel to this, right? This now you can do it, right? I don't want to now tell you how to do it. You can do it easily, uh, very clearly you can do it. It is more comfortable than the previous ones. The coordinates of the foot of the perpendicular drawn from the point this on x-axis. It's a very basic problem. This can be given in uh, class 11 also. So you just see you are having this x-axis, y-axis, and z-axis, and there is a point 0, 1, 2. X is 0, right? X is 0 means you are starting x here. Then for y-axis 1 and for z-axis 2. So can you directly see from here where is the point lying? The point is lying on the zy plane or yz plane, right? It is just pasted in the yz plane. So they are asking you uh, what is the perpendicular foot of the perpendicular drawn from this point to x-axis. So where is the x-axis? So from here, if you draw the perpendicular, what will be the foot? You have to find the coordinate of this. So obviously it is 0, 0, 0. At origin only you can draw the perpendicular. This is a very good question. It can be given in class 11 also. Okay, now there is a problem which is assertion reason problem, right? I don't know whether I am moving it with high speed or not. Maybe to cover more problems, I am moving with high speed. So please try to maintain the pace. Okay, let me be a little slow. A line in space cannot be drawn perpendicular to x, y, and z axis simultaneously, right? So if you are drawing a line perpendicular to x axis, y axis, and z axis simultaneously, the angle should be what? 90, 90, and 90. So their direction cosine should be what? 0, 0, and 0. This cannot be direction cosines because there some squares का sum 1 नहीं है. So this is false, right? If this is false, then I think you need not check the other one because this is the option C. In competitive exams, there are possibilities, but here it is not option C, option D. Assertion is false, reason is correct. So you can get it very quickly, right? This risk you can take in board exams because if you get one of them to be false, then obviously other will be true in case of your CBSE board because we have only four options. Find the shortest distance between these lines, right? So here, actually, I just want to tell you about this. Because of that, I am going to do the problem. The first line is already in the uh, standard format. So here, if I compare, what is A vector, A1 vector? A1 vector is 2 I cap minus j cap plus 3 k cap. Please listen to me very carefully. B1, don't write below A1. So in the side you write. The B1 is I cap minus 2 j cap plus 3 k cap. Now from here you can directly write what is A2, right? A2 means those which are not related to this constant. Oh, acha, here too they have already segregated. Sorry, I thought it was mixed. So very easy to write. Okay. Then B2 vectors are what? 3 I cap minus 6 j cap 9 k cap. Acha, did you observe anything here? Now I'm going to tell you a very important thing to do this problem, because many a times it is misleading. Before you put any of the formula, before you put any of the formula, please mind it, you check the ratio of these components in rough, right? So या फिर आप दिखा भी सकते हो. Here I can write it like this also. I can take 3 common, then this will be 3k, and I can write what? This is 3 times b1. So what did you observe? You observe that b1 is, I mean b2 is scalar multiple of b1. It means the vectors are parallel. That means lines are parallel, right? Therefore, lines are parallel. Why I am doing this? Because if lines are parallel, their formula is different. Their formula is different. What is the formula? D equals, what is that? It is A2 minus A1 cross B divided by magnitude of B. So now you please do this. How you will do it? A2 minus A1. See, if you write it one below the other, you can do it quickly. So this will be minus I cap, then 4k it is. So it is J cap, and then this is K cap. And then cross product with this. The first one you take, the reduced one, 2J 3k. So you can name this as vector B, because in the formula you are using B. Okay. Now below it is magnitude of B. What is the magnitude of B? You can write this as 1 plus 4 plus 9. 1 plus 4 plus 9. Right? So the cross product you can easily find. You can find the cross product, and then you can find the ultimate result. So cross product, how can you do it in quick manner? See these numbers, just see these numbers, you write 1, 1, 1, and then here it is 1, minus 2, 3. And then again you repeat this line, minus 1 and 1, right? So how you'll do the cross product? For I cap you cross this. So here this is, I'm writing the factor 3 plus this 5 I cap. Then for j cap you have to cross this. So this you multiply 1 plus 3, that is 4 j cap. And lastly you come to this 2 minus 1, 1 k cap. So this is the cross product. That means the result of this. So now you have to find the magnitude of this, because already magnitude is there. So what is the magnitude? I'm writing the distance here little indisciplined manner, because there is no place here, or I can write here also, no problem. Let me write here. Then after notes will be understood. So your magnitude will be here, root over 25 plus 16 plus 1, and below it is already 14. So 25 and 15, 41, 42. 42 by 14. So 14 threes are, actually it will be root 3, right? Root over 14 into root over 3 will be there. So root 3 unit is the distance. So you can see that. So this is actually a 3 marks problem now. So be very, very clear about this particular part in the problem. यहाँ पे बहुत लोग मिस्टेक करते हैं, because if you find b1 cross b2 directly without listening to this, without checking this, you will get always zero vector, and you will say that this shortest distance is 0, but this is not the case here. Next, find the distance between this line and another line parallel to it passing through the point this, right? Another line parallel to it passing through this. Actually this is a very good question. The previous question and these questions are same. That was in the vector form. This is in the Cartesian form. So I'll write it little. The rest you can do. Just see it. First line is, I can write like this. First line in vector form, because we find here vector form more comfortable. Form is, what will be the line? Can you write it? Vector form. So it is R. The point will be written here, and then parallel vector will be written here. So point will be 0. I cap is 0. So I'll not write I cap for that. And then here what I can write, the point will be what you try to see. In the standard form, it will be y minus 3 by 2. So it will be 3 j cap. Be very, very alert about that. And this will be reversed, z minus 1. Z minus 1, that means it is k. Then here it is okay, 2 I cap. This vector will be as we have decided 2, and the last one will be plus, actually plus k cap, right? And now they are saying that you have to find the distance between this line and another line which is parallel to this but passing to this point. So point will be only different here, but the vector to which it is parallel is same, because both the lines are parallel. So now it is B, this is A1, this is A2, and you apply the formula. What is the formula? Okay, I'll write it here only, so that you can remember that this is A1 vector, this is A2 vector. These both are actually not B1, B vector, because they are parallel, and your shortest distance formula is A2 minus A1 cross B vector divided by magnitude of B. This is the formula you have to use. Be very, very clear about that. Many students missed out this. It's a last year problem, I think. Okay. Write the vector equations of the following lines and hence find the shortest distance. So this, I think, is not a very wordy problem which I should do. Vector equation should be written. So I just write the vector equation. You can find the shortest distance. So vector equation for this line will be what? R. And then here you should write the point. Again, I am saying you, here you should write the parallel vectors. That means the direction ratios, whatever vector they will form. So the point will be, first will be minus I cap, second will be minus j cap, third will be minus k cap. And then here it is 2 lambda minus 6, so lambda times 2 j cap, I mean 2 I cap minus 6 j cap, and then k cap. This is one. What is the other in vector form? 3 I cap plus 5 j cap plus 7 k cap, and then use different constant here or parameter, I cap minus 2 j cap plus k cap. Again, a statutory warning, don't directly write these values because they may not be in the standard form. Once you get it, your formula is ready. What is the formula? I again would like to write, because many a times if I write the formula, my concrete this remembrance will be there, right? So it is dot b1 cross b2 divided by magnitude of b1 cross b2. That's it. So you can use it. I don't want to waste time here doing this, right? It's your thing. You will do the practice. Find the length and the coordinates of the foot of the perpendicular drawn from this point to this line. Also the coordinates of the image of the point. This is a big problem, right? This is a big problem. It should be 5 marks problem. I don't know whether there's a 5 mark problem or not. I did not notice while copying this, but this is a very big problem. There are 3 parts. So first of all, they are asking you to find the foot. Then they have to, you have to find the length of that perpendicular, and then also the image, right? So I'll be doing this because this is one of the important question which is most probable in your next. My line is this. This is my line, right? Given line is this. Fine. I'll write the statement as given line is this, and then I'll write this as 1. Okay. This is the point from where I have to draw the foot. 593. Right? I have to draw the perpendicular, and then I have to find the foot, and at the same time I have to find the image. So together I have extended up to this. Say this be the image, which let me not write this as alpha because first I'll find the foot. Let me write this as alpha beta gamma. Right? This is alpha beta gamma. This is say ABC. I don't want to use because ABCs are used for direction ratios. So say I'll write alpha dash, beta dash, gamma dash. Afterwards, I'll find what is alpha dash, etc. So now, first thing, what I noticed here, please be very careful about that. This is the foot of the perpendicular drawn from this. So this particular point is lying on this particular given line, right? So that means this M is going to satisfy this. So how do I write the statement? Let M alpha beta gamma be the foot of the perpendicular from P to line 1. Okay, fine. This is done. So what I can write, 1 implies, right? 1 will imply what? You put alpha, beta, gamma in respective positions of x, y, and z. So you will be getting alpha minus 1 by 2, which if I equate to lambda, I can get what? Alpha equal to 2 lambda plus 1. Similarly, beta, if I equate this quantity, I equate to lambda, I will be getting this as 3 lambda plus 2, and gamma will be equal to 4 gamma, 4 lambda plus 3. Right here, what is that? Lambda is a parameter, which is nothing but a scalar quantity called uh, parameter. So I can find a relation of alpha with lambda. The first step is done. That means now I can say that alpha, beta, gamma has been expressed in one single parameter. Fine. The next condition you try to say. According to the condition, this line is perpendicular to this. So, component wise, if I multiply their direction ratios, that algebraic sum is 0. That means 2 times what is the direction ratios of PM? That also you can write formally, right? So, I'm writing that also dr of PM. What will it be? Alpha minus 5, then beta minus 9, gamma minus 3. At this point, I would like to put these values, right? In alpha, I'll put twice lambda plus 1. So I'll be getting this as twice lambda minus 4. Beta, this value I'll put. So 3 lambda minus 7. And then this is 4 lambda, only 4 lambda because 3 and minus 3 will get cut. So I got the direction ratios of this line PM. But PM and 1 are perpendicular. Please see the link. Now I'm going to add a page. So I can write, but PM is perpendicular to line 1. So my product of the direction ratios component wise, that sum will be 1. So 2 lambda minus 4 into 2. 2 lambda minus 4 into 2 plus I'll be getting this as 3 lambda minus 7 into 3. 3 lambda minus 7 into 3. And then 4 lambda into 4. This together makes it 0. So now from here I have to find the lambda. So it is 4 lambda. Don't be in hurry to find this. Otherwise, one small mistake can be very dangerous for you during exam. Okay. Now this is what 16 plus 9 will be 25. 25 plus 4 will be 29 lambda, and the rest will be also 29. So lambda equal to 1. This is the next important part. So lambda you got already, alpha, beta, gamma, you got it in the form of lambda. Now really you can find the alpha, beta, gamma, which is nothing but the food. So let me work this out. Lambda equal to 1. So if I put lambda equal to 1 here, alpha will be 3, beta will be 5, and gamma will be 7. That means 3, 5, 7 are respective coordinates of the foot. So I'll write, therefore foot is 3, 5, 7. That is the coordinate of the foot. So I got this. Fine. I got the foot. Now this is a long problem. Again, I am telling you. After getting foot, you are not done. This is the first step you did. Then you have to find the length of the perpendicular. That means you have to find the distance of PM. Distance of PM. So 593. Okay. So also length of the perpendicular, that is equal to PM. That is nothing but you use the distance formula. 593 was the point. So it is 5 minus 3 whole square, 9 minus 5 whole square, 3 minus 7 whole square. Let me just check it. 593. Yes. So I'm done with this result now. It is 4. It is 16. It is also 16. So 36 is coming. That is 6. So length is 6 units. And at last I need alpha dash, beta dash, and gamma dash. That is the image. Also you can write, also M is the midpoint of PP dash. Therefore, what you can write, alpha dash is equal to, not alpha dash, I just alpha equal to, right? Alpha equal to alpha dash plus 5 divided by 2, beta equal to beta dash plus 9 divided by 2, and gamma equal to gamma dash plus 3 divided by 2, right? So you have got this alpha equal to 3. So from here you can get alpha dash. Alpha dash will be 1. Beta is equal to 5. So beta dash plus 9 divided by 2. So beta dash is also 1. And gamma is 7 here. So I can find gamma dash also. Gamma dash is 14 minus 3. 14 minus 3, 11. So your image is 1, comma 1, comma 11. That answer I am not writing. So you finally write the answer. But again, I would like to tell you that this is a big problem because there are 3 important parts. And if you practice one such problem, you are reviewing all the 3 concepts. Very nice problem. Okay, next, coming on to this problem. Let's see what is there. Find the equation of a line L2 which is the mirror image of the line L1 with respect to this line, the with respect to this line, given that L1 passes through the point P1, 6, 3 and parallel to the line L. This is a very good problem because this kind of problems are not there in the textbook. So you have to understand, right? This problem is, I think, from 2024, not 25, right? So let us just frame the problem, but we'll be able to do it. I have to find L2, right? Which is a mirror image of the line L1 with respect to this line, right? So first I'll write this line L. Suppose this is the L. this given line L. Okay, fine. Then I have to find the equation of L2, which is mirror image of L1. Mirror image of L1 with respect to this. That means it is the line L1, mirror image of L1. L1 is the line. Right? Now, this line is L1. L2, which is the mirror image of L1. L2 is the, this is L2. L2 is the mirror image of this. Right? Mirror image of this. And given that L1 is passing through this point. L1 is passing through this point. Now you see, you have to understand this problem very clearly. Understanding is the main part here. You have a line L1 which is passing through the point 1, 6, 3, and L1's mirror image on this is line L2. I have to find L2. What is L2? Now, how we can find it? This is very, very important, right? So, mirror image of this. Find the equation of line L2, which is the mirror image of the line L1 with respect to this line, given that L1 passes to the point on this and parallel to L. Oh, this part is missed out. Because of that, I have drawn the wrong figure, right? Actually, it's a parallel line. They have told you to find. Now it will be easy for you to do. It's a line. This is L1 passing through the point 1 comma this, and now here this is L2. And now you have to find this equation. Actually, all these three lines are parallel. So only thing is that I have to find one point on L2. That is the main thing you have to do. So that point easily can be found. Just find the image of this point here. Just find the image of this point here, because as all the three lines are parallel, my direction ratios for all the three lines will be 1, 2, 3 only. One part is finished. What I need to know is only a point here, only a point here on this line. So what does it mean? Indirectly, you have to find the image of this point with respect to this line, then you will be getting this point. So you know the direction ratios of this line to be 1, 2, 3. Once you can find what is this point, then you can use one point, and that first step, that is the equation of a line passing through a given point and parallel to a given line, can be used. That is a very, very important problem. So now, as I did the image problem just before this problem, so I don't want to again repeat the entire process. So you just find this and you find the image of this directly and then find the equation of this line. This is really a very good problem. It's a good problem, right? So please try to understand that. Okay, now again you can see the image of the point this with respect to this line is p dash 1 comma 0 comma 7. Find the coordinates of the point p. Now you see this is actually a trick, nothing else. They are asking you to find the image only, but this time they have tried to play the trick with us. How it is played? Earlier they used to give this point. They were asking you to find this, but this time they have given you this point and they are asking you to find this, but line remains the same. Line is already there, the previous one what we got like this only. So can I now just revert the problem? Instead of finding image of p to be this, can I say the reverse one, that image of p dash is this, Can I now simplify the problem by saying that you have to find the image of P dash treating this line as the mirror? So your problem is reduced to a known problem. So this is a very good twist, but the problem is easier, right? Easier at the same time important as well. Okay, please do that yourself. Okay, I'm coming to the next. This is a good problem again. Equation of the sides of the parallelogram ABC are AB, BC, CD, DA. There is a parallelogram. All the four sides are given to you, and you have to find the equation of the uh, diagonal. Suppose this is the parallelogram. I want to write ABCD like this. I know all the equations. These are parallel. These are parallel. I have to find the equation of the diagonal BD. I have to find this, right? BD I have to find. Equation of this. So to find the equation of this, what I need to know? Just you try to think. If I get those things, I can easily find the equation of this particular diagonal, right? I need to know only what is the point of intersection B and D. So you see, B is the point of intersection of AB and BC. That means this if you solve, you'll be getting point B. This if you solve, you'll be getting the point D. And then you can find the equation of this diagonal simply by using 2 point form. That is the second type. So now, because I haven't done any problem in this session by which we can solve or find the point of intersection of two lines, so one part I'll show you. I'm going to find now the point B, coordinate of point B, by solving AB and BC equation of this. So let me give the name, or I can say number, to these lines because I have to eventually refer to these points, right? So how would I do it is any point on 1 is of the form. What will be the form? It will be, can you directly consider this equal to lambda and then you can talk about the points? You can directly say that. How will say x will be, that is lambda minus 1, then minus 2 lambda plus 2 and 2 lambda plus 1. Any point on equation 2 is of the form. Equation 2 is of the form. What will be the form? This is 3 mu. This time I consider this as mu. You need not write it here. You can directly write 3 mu plus 1, then minus 5 mu minus 2, then 3 mu plus 5. So I have found the structure of the point on AB and BC. But if I should find what is the point of intersection of AB and BC, then obviously there should be some value of lambda and mu, replacing which will generate same equal value for both this. That means I can write for B, I should definitely get lambda minus 1 must be equal to 3 mu plus 1. This is one result. Minus 2 lambda plus 2 equal minus 5 mu minus 2. Then 2 lambda plus 1 equal to 3 mu plus 5. I got three sets of equations. Now I have to solve them. So I think this is one of the easiest one. So let me keep lambda from here. So I'll be getting 3 mu plus 2. Say this is 1 dash. Now I'd like to just put the value here, right? I'll put the value of lambda here directly. Let me not wait for any kind of simplification process. So if I put lambda here, minus 2 से मल्टीप्लाई करेंगे तो दिस इज 6 म्यू प्लस सॉरी minus 4 plus 2 5 mu minus 2. Let us just try to see what will be the value of mu from here. right? This also I have to do. So directly you can find mu. This side it will be 11, then this will be -2, and yes, mu will be 0. Mu will be 0. Okay, let us get the same mu from this. If I get the same mu from this, then I'm done actually. So here also I'll put twice lambda is 6 mu, then plus 4 plus 1 is equal to 3 mu plus 5. Yes, this also gives you mu equal to 0. That means in both the cases you get mu 0. So you are successful. Therefore, mu equal to 0 and lambda also you find from here. What will be the lambda? Lambda equal to 2. Now, if you put mu equal to 0 here, you will be getting the point. If you put lambda equal to 0 here, you will be getting the same. Lambda equal to 2 here, you will be getting the same point, right? Therefore, b equal to, what will be the b point? Mu equal to 0 you put, then it will be easy for you. So 1, then here it is -2 and 5. So you got the point B. Now exact similar process you apply for AD and BC, that is line 3 and line 4, to find the point D. And then if you get 2 points, you can really think about the equation of diagonal. This is also a bigger problem, and I can remember this is a problem of 5 marks, right? So obviously, because you have to solve it. Let me look for other possibilities also. There may be other process also. Let me see if it is okay. But as of now, this is coming to my mind, and I'm done with this. Right? I have done half of this. Please try to find from here. You have to find what is the BD D point. Then you find the equation. Good. Next, if the lines this and this are perpendicular to each other, find the value of k and hence write the vector equation of the line perpendicular to these lines passing through the point 3 comma minus 4 comma 7. This is also a good problem, right? They have integrated two different concepts, right? One concept is your perpendicularity, and then they have used another concept, right? That is concept of cross product. So we are going to do it, right? We are going to do this because this is one of its kind. We haven't got this kind of problem earlier. Let me first find what is the conditions, right? So line 1 is given lines are what are the given lines? The first line is this. This is the given line 1, and the second line is x minus 1 divided by 3k, y minus 1 divided by 1, z minus 1 divided by minus 7, z minus 6 divided by minus 7. Okay. So now we are having these lines. According to question, 1 is perpendicular to 2. So what will happen? Minus 3 into 3k minus 9k, then plus 2k, and then minus 14 is equal to 0. So I can find directly the value of k. It is minus 7k, minus 2 will be there. Value of k is done. The first part is done for you, right? Now I need to find what you see. Write the vector equation of a line perpendicular to these two lines and passing through this point. So if these two lines are there, I have to find the new line which is perpendicular to both of this, right? So let me find this. First of all, these lines now, because I have to find some product with them, I would like to rewrite them by putting the value I got for k. For k I got -2, so this will be -4. This is 1, and here also I would like to write x minus 1, then y minus 1 by 1, z minus 6 by -7, right? Let the line be. Let the record line be. My record line is passing through this point, so I can directly write x minus 3. I don't know what is the direction cosine, so direction ratio, so I have written this as a, b, and c, right? So this is my record line, and this line is perpendicular to both 1 and 2, right? So you can use the conditions, right? So what you can write, according to question, 1 is perpendicular to, say, this is star. 1 is perpendicular to, we can use the vector product also, right? We can use the b1 cross b2, then I can use them as the component of this abc, I mean value of abc, that components. So that way also I do, but here I am doing in an extensive way. So here if they are perpendicular, I can get what, -3a -4b plus 2c equal to 0. Then line 2 is perpendicular to star, that gives you what, -6a, then b, and then -7c equal to 0. So now how will you solve? Actually, I want to show you the solution of this, because of that I have adopted this. Otherwise you could have done by doing the cross multiplication also, cross product also. So therefore solving, we solve these equations. So this is the cross product method or cross multiplication method of solving these kind of equations, where the answer will be getting in proportions. So below a, if you want to write this, you cross, then you multiply this. There's a -4 -7 multiply, we get 28, and then this is +2. If I write for b, I should reverse the multiplication. This is -12, and this is -21, and here it is 3, and then -24. So what I get here as a by 30, b by 33 -33, and c by -21. So every number is divisible by 3. So I want to go for the next page, so that clumsiness will not be there. I get by 3, if I divide it will be 10, then next is -11, and last one is 21, so -7. So you got the value of abc. So now this abc you put here, your equation is okay. This is 10, 11, -7, right? So x minus 3, therefore star is giving you x minus 3 by 10, then y plus 4 and z minus 7, y plus 4 by this, and z -7 by -7. So this is the record line. So this is a good question. Please try to see that. Okay. The vertices of triangle ABC are 1, 1, 0, 1, 2, 1, and -2, 2, -1. Find the equations of the medians through A and B. Use this equation so obtained to find the coordinates of the centroid. So here if I explain you the problem, You can do this problem yourself. It is not a difficult problem. So I just draw a figure. My suggestion is that whenever you get a possibility, you draw a figure for it. It will illustrate everything very, very clearly. So this is the point A, this is the point B, and this is the point C. What I need to find, I know all these coordinates, right? Let me write this, then it will be easy for me to refer. 1 to 1, and then -2 to -1. So what I need to find is median from A to the opposite side. So now here you have to recall what is median. Median means median means the line segment joining the vertex of a triangle to the middle point of the opposite side. So because you know these two coordinates, you can easily think about the middle point of this, right? How can you find? You find this, it is -half, then it is 2, and then it is 0. Now, once you get the middle point, can you find equation of AD? Can you find equation of AD? Yes, easily equation of AD can be found. How equation of AD will be found? Equation of AD will be found by using the 2-point formula, that is second type. So I'll use this as x1, y1, z1. So my equation of AD will be x minus x1 and then x2 minus x1 below it is, right? So half minus 1, then y minus y1, then y2 minus y1, that is 2 minus 1, then z minus 0, then 0 minus 0 here. So ultimately I get the reduced form. Let me write it. It is -3 by 2, y minus 1 by 1, z minus z by 0. So this line I can still manipulate by multiplying it by 2. I can even multiply it by -2. So anyway, I have simply multiplied by 2. So this is my first median, AD. Now, if you observe, they are asking you to find the second median also. So for second median, what you will do? From B, you have to join the middle point. So you give the name of the middle point as E. E can be easily found, right? So if you find it, it is -half, then 3 by 2, and then this is -half. So now you know the point B, you know the point E, so you can find equation of BE. Similar that I found for AD. This I'm not going to completely do. So this way you can find the equation of the other median. But after that, the main part is left out, that is find the centroid. So again you have to remember, see the conditions. If you're not remembering those simple plane geometry from class 7, 8 or 9 or 10, here you will not be able to do the problem. So now I can remember that whenever you draw two medians, wherever they will intersect, that is the centroid. So I have got median AD's equation. You will find median BE's equation. And then if you solve them, you will be getting their point of intersection, which is nothing but the centroid, right? So I leave this part. Similarly, you find the equation and point of intersection. Point of intersection, already I have explained you how to find it. Okay. Next, it's a very good question. Find the equation of the line passing through the point of intersection of this line and perpendicular to these lines, right? So actually these questions are more or less same type. So you have to first find the point of intersection of these lines. How do you find the point of intersections? You have to find the arbitrary point on this. Already I show you how did you find it. It will be lambda. Then a point on this will be, you will equate this to lambda and you will say that point will be of the form 2 lambda plus 1, and then z coordinate will be 3 lambda plus 2. Similarly, here for this you consider mu. So the first or the x coordinate will be 1, second y coordinate will be minus 3 mu, and z coordinate will be 2 mu plus 7. And now to get the point of intersection, there should be some value of mu and lambda for which both the x coordinates are equal, both the y coordinates are equal, both the z coordinates are equal. अब इनको लिख के सॉल्व करके म्यू एंड लेमडा निकालो, देन आपको पॉइंट मिल जाएगा. Once you get the point, you can find a equation perpendicular to both of this, right? If you observe the previous part of the class, यही session का, then you will find both these problems I have done. So I am not repeating here now. So you have to just see 2-3 problems back to this. So, but this is a very important problem. Next, 23. Actually, I am skipping these problems which are repetitive in nature because I don't feel that if I do all the problems, it will help you in any way. I am doing the problems as a sample ones so that you can get the idea, and whatever problems are left out, you can practice it and you can finish it, you can prepare yourself. Okay. Two vertices of a parallelogram ABCD are given as A and B. If the equation of the line passing through CD is this, then find the distance between AB and CD and find the area of the parallelogram ABCD. So this is a very good problem. This problem is not directly there in the book, but we can bring those concepts, whatever we already know from the book, right? So it's a very interesting problem. Seems difficult, but it is not a difficult problem. It's an easy problem. So I'm explaining you. First, you write whatever is known to you. So ABCD is a parallelogram. I know these points 1, 2, minus 1, 2, 1, and 1, minus 2, and 5. These 2 points are known to me. Fine. Then they have told you that line equation of the line passing to CD. Indirectly, I can say equation of CD. They have given you these things, right? AB are given and the line passing to CD is given. Now they are asking you find the distance between side AB and CD. AB and CD, you have to find the distance between them. Now, how would you decode it? That's the only thing. I have to find the distance between them. So, what distance? They are nothing but perpendicular distance. So, now can you justify what they are saying? They are indirectly asking you to find the distance between two parallel lines. So, it is one of the parallel line. You have to find the other parallel line. What is the equation of the other parallel line? What is the equation of the other parallel line? You can find this. This is number one. Or else, if you try to observe it more meticulously, you may not have to find the equation of the other line, because if you think this line to be extended, from here only you can find the perpendicular distance. That itself will also work as the distance between these two lines. Now choice will be totally up to you, but I suggest you find the equation of this line. So what is equation of AB? Equation of AB is x minus x1. Let me consider this as x1 divided by x2 minus x1. Then y minus y1, y minus y1, then y2 minus y1. That is this minus this is minus 4, and then z minus z1, z2 minus z1, that is 4. Now you see these are having some common factors. Because these are direction ratios, you can really cancel that common factor, and you can observe that these lines AB and CD are parallel. So now you find the distance between this line and this line. Can you think of the perpendicular distance formula between, or the distance between two parallel lines? I did it in the beginning only of the session, right? When I started with maybe in MCQs, or maybe with the subjective problems. So you have to go back to the first or second problems. So then you take the idea how we find the distance between two lines which are parallel to each other. So that distance you have to find, and then find the area of the parallelogram. It's a very easy thing. I do it, right. Distance I write like this. Distance you have to find. So what will be the area of a parallelogram? Can you still recall area of a parallelogram? Area of a parallelogram means base into height. So base means you can consider AB, right? And height means whatever distance just now you find. Say it is D, right? So this is a very good problem. So if you really have an in-depth concept on this particular idea, then only you can easily decode this. But it is not a difficult problem. I'm not saying it is difficult. Please try to understand. Good. Find the shortest distance between these lines, right? These are left for you. You will do it directly. Direct questions. Okay, find image A dash of this point in this line. Also find the equation of the line joining A dash. Find the foot of the perpendicular from the point A on the line L. So this is again a repeat question. I already did this. I already did this. You have to find the image of this line here. At this point on this line, that is known as A dash. Once you get A dash, you find the equation of A dash. Or second type you can use. And then foot of the perpendicular. Of course, while finding the image, you can easily find the foot of the perpendicular also. So the entire problem is already done. So I don't want to again reinforce these things. Please see that. Verify that these lines are skew lines. Hence, find the shortest distance. How will you verify that these lines are skew lines? So you try to remember one by one the points. Skew lines are those which are neither intersecting nor parallel. How can you verify that they are not intersecting and not parallel? First, parallel can be identified by looking at the vector component of B1, that A plus lambda B1 and A plus lambda B2, that B1 and B2 you check from here. If they are parallel, line will be parallel. If they are not parallel, then the line will not be parallel. So that only you have to verify. So little help I am going to give, not completely. The first line I would like to write in this particular form, and this you can directly write. In this case, you put all those components which are free from lambda from the first line. So it will be 1 into I cap. Then it is minus 2. So it is minus 2 j cap. And it is 3. So it is 3 k cap. Then with lambda you write here in this. So it is minus I cap. Then it is plus j cap. And lastly, it is minus 2 k cap. So you got this as say B1, right? Okay, this is A1. You have to be very, very alert about understanding this. Now, second is having mu as the parameter. So here you write I, then minus J, and then minus K cap. And here mu for this I cap, and then 2J cap, and then minus 2K cap. Here it is B2. So we have written them in the standard form. अब यहां से बोलो क्या B1 B2 parallel है? I can verify also. How can I verify? I can verify like this. B1 directly I'll write B1 is not sorry, I should write parallel. B1 is not parallel to B2 as you just see the components ratio. First one is -1, here it is 1. Then it is 1 and here it is 2. So they are not equal. Had they been parallel, this would be equal. You write the third also, -2 and here it is -2. So none of these are parallel to anyone. So they are not parallel. First thing is done. And next you find the shortest distance only. If the shortest distance is 0, line will be intersecting. And if the shortest distance is not 0, then line will be skew lines. Right? So that's the thing. Next is to find the shortest distance. So shortest distance already you know how to find. So I'm not doing that. Please find the shortest distance. These are actually very important problem because one problem is collecting 2 3 concepts at a time. So this problem makes the paper little longer. So you must be practicing it very well so that your speed will not be reduced due to these problems. Right? Okay. Next, find the image A dash of the point 1, 6, 3 in this line. Also the equation of joining. Actually, this is a repeated question if you observe. Right? 2 or 3 slides back only we did it, but that representation was little bigger. There they have asked you to find the foot. They have asked you to find the equation of A dash like this. Right? So same problem repetitive. Find a point P on this line such that distance from the point this is 7. Also find the equation of the line joining PQ. This I am going to do. So there's a line. This is the line. It's the given line, right? So let me write this given line. Y plus 3 by 4. Z minus 6 by 9. This is my given line. And you have to find a point P here. Say this is the point P. I have to look in this pink line such that its distance from the point, another point is there somewhere. Say 2 4 minus 1. Let me just check once more. क्या ये point इस line में तो नहीं है? Let me just see it. Sometimes it may be. So if I put here, it is 7 by 1. That is result is 7. Then if I put 4 here, 7 by 4, so they are not equal. That means this point is not satisfying. It means this is not lying in this particular pink line. Okay. They are saying that this distance should be 7 unit. This distance is 7 unit. So you have to find a point on this line. So there can be 2 points, this side also, right? So let me just think about one line only, 1 point only. Now, can you tell me that what is the shape of any point on this line? So you write given line is this. Given line is this. This is number 1. Any point on 1 is of the form. What will be the form? It will be lambda minus 5, because this will be multiplied by lambda and this point will be taken to the other side. So minus 9 lambda plus 6. Any point on line 1 is of that form. That means in particular P भी वैसा ही एक form bear करेगा. So P, I can consider that there is some value of lambda for which P is this point. Now it's a simple distance formula, you see. It's a simple distance formula because you can find the distance between this and that equal to 7. You solve for lambda, you'll be getting 2 values of lambda. One value of lambda will give you this P, another value will be giving you the other one. Similarly, 2 points you will get. They are asking that only. And at last, they are asking you what is the equation of the line joining PQ. That means, again, they have given you some tail part, 1 mark, 2 parts will be there. Right? So that is, it's a long question again. I'm telling you, half I did, then you have to now solve this. According to question, PQ is equal to 7. Then PQ square is equal to 49. and then you use uh, this minus this, that is lambda minus 7 whole square, then this 4 lambda minus 7 whole square, and then this minus this, that is 9 lambda minus plus 7 whole square. This is equal to 49. You solve this entire equation for lambdas, and once you get lambda, you will be getting p. Then you find what is equation passing through PQ. So you can get it. Good question. Find the angle between the two lines given by this. So here, angle to directly you can do. We have already done in multiple choice. Only thing is that how would you convert these lines in the standard form? So that part I'll do. The rest you can do yourself. So the first one, I write it here itself. So below it is what? 1 is there. So I have to remove this 2. So I divide by half. I have to remove this 3. I divide by 3. I have to remove this minus 1. So I divide by minus 1. But you may be keeping this as this number only. Let me see for the other fractions, right? So here it will be what? Below it is 1 only. So when you convert this, it is 1 by 6. Then it is y by minus 1. Then it is z by minus 1 by 4. So I think it is not wise to keep them as the fraction. So you multiply by the common LCM, the LCM. So 6, if you multiply, it will be 3, it will be 2, and it will be minus 6. Then here, if you multiply, it is 1, y, it is minus 6. Sorry, here 12 you have to multiply. If you multiply, this will be 2. If I multiply this by 12, it is 12 only. And here, if I multiply 12, it is 3. So you have already converted in the standard form. So what is the angle? If you consider angle as theta, so you multiply this 3 into 2. This is 2. 3 into 2, 6. Then 2 into minus 12, minus 24. This is plus 18. Oh, you can see that this becomes 0. Right? Below you can find only this becomes 0. So 0 means theta is pi by 2. Good question. It's a 3-mark question. Find the shortest distance between these lines. These are very direct questions. There is no point in discussing this. You can do. Find the shortest distance between the line L1 and L2. L1 is passing through this and parallel to this. So first you have to make ready the line L1, and then L2 is given directly, but still it is not given in the standard form like A plus lambda B or mu B. So you have to put this also in that form, A plus mu B, and this other line equation you have to find, then you have to find the shortest distance. So now, have you noted how important this question is? The examiner or the paper setter wants to test you with this simple question, more or less maximum concept you gain in 3D. First, do you know the first form of line? Secondly, do you know how to get the standard form? Do you know how to find the uh, shortest distance between these lines? Right? This is very, very important. And on the top of everything, once you get the lines, don't directly start finding the shortest distance by the formula. I already discussed this. You try to check whether lines are parallel or not. Sometimes lines will be parallel and then you will not be able to do. You'll be getting 0, right? So be careful about that. That is a conditions always you remember. Next, find the coordinates of the foot of the perpendicular and the length of the perpendicular drawn from the point this to this line. This problem was also done. Foot of the perpendicular we have found, even image we have found, and length of the perpendicular I can still remember. I have found in some problem distance between P and M, right? That was M was the foot and P is the given point. So similarly you can do it. Find the coordinates of the foot of the perpendicular drawn from this point to this line, right? Find the perpendicular distance of this given point from the line. Are not they the same problem? They are the same problem. Only care must be taken. You see, this is not directly given as in the standard form. 4 minus x is given, not x minus 4. So you make it x minus 4 by minus 2. Y by 6 is okay. 1 minus z is not correct. So you have to make it z minus 1 divided by minus 3. And then only you proceed ahead. Please do it yourself. That will be a homework for you. I mean, practice for you. Homework, not homework. Find a point Q on this line at a distance of 3 root 2 from the point 1 comma 2 comma 3. So here also you will be able to do. I'll just frame the question so that you can understand. This is the line. This is the line given. I'll directly write it in the standard form. What is your line? By 2 I have to divide, right? So my line in the standard form will be x plus 2 divided by 3, y plus 2 or y plus 1 divided by 2, then z minus 3 divided by 2. Z minus 3 divided by 2. I have done the line in the standard form, symmetric form. Then find a point Q on this line. Suppose this is the Q I have to find, which is at a distance of 3 root 2 from the point P 1 comma 2 comma 3. I am again giving you the informations alert. This point don't just simply put outside. Once you check, who knows this point is lying here only. So let me put here 1, then 3 by 3 means 1. 2 if I put, it is 3 by 2. That means they are not equal. It is not satisfying. So this distance is given to be 3 root 2. And then they are asking you to find this Q. You will be getting 2 points. You can remember, just extensively I did this kind of questions just before few slides. So I leave this for you. Find the image of the point minus 1 comma 5 in the line. This, find the length of the line segment joining the points, that is a given point and the image point. Image निकालना आता है, so you can do it, right? I don't want to again do it, because see, today's material, this class notes or whatever class note I'll share after the end of the class to you, you get a very good material to practice. Sometimes what happen in this particular time, you are hunting for questions what you are not getting. So these are assorted questions. So definitely I request you to go through each and every problem of this, finish it and do it with your all might. Because this is a common problem. This gives you a very good practice. Okay. So find the angle at which the given lines are inclined to each other. See the trick. They are not saying you find the angle between them, but indirectly they are asking that only. So angle to you can find only here it is A, here it is B, and here it is C. Here it is A dash, here it is B dash, here it is C dash. So you can directly find the angle, right? I leave this for you. Let the position vectors of the point ABC are respectively this. Find the vector and Cartesian equation of the line passing through A and parallel to BC, right? So here also you can just construct a rough figure. Suppose this is the line passing through the point BC. Their position vector is known to me, and this is the point A. I have to find a line through A which is parallel to BC. They're asking you to find this only, right? So is it not a direct problem? Once you confirm it in the form of figure, it's a very very direct question. See, you know B and C, because this is the coordinate of B, this is the coordinate of C. So vector BC easily you can find. This is nothing but position vector of C minus position vector of B. That means directly you can find it only. This minus this is 0. Then 5 minus 2, it is 3j cap. Then 3 minus this is 4k cap. You got BC. And now through this point, you have to find a line parallel to this. It's direct equation आ ही गया है, ये 2 मार्क का होगा या फिर maximum 3 मार्क का. So your equation will be what? This here coordinate of the point A, and then this is lambda times BC, that is 3j plus 4k. This is the answer. I think this is not a 3 marks question. It is 2 mark question only. Easy question. Find the distance of this point from this line. That means they are asking you to find the perpendicular distance. So here I would like to just tell you one new method. A new method. Two methods I am going to discuss. One already I have done, finding the foot and then find the distance. But there is one more interesting method, right? First, let me explain what usually we are doing. This is my line, and suppose this is the point P241. What usually we are doing is that we draw a perpendicular, we find this point, and then we find with the help of distance formula this particular distance. Absolutely correct. Absolutely correct. But what alternatively we can find is this. Please see that. This is a very interesting problem. You have this point P24 minus 1, right? And in this pink line, looking at this equation, if you look at this equation, you can find that there is a point lying here also. What is that point? कहीं भी हो सकता है. Let me just consider here. It is -5, -3, and then 6. Suppose this point is say A. Now, how do we find this? Very, very interesting. You join this, right? And also you join this. This is perpendicular. Here we don't need to find the foot because they are not asking us to find the foot. They are asking only us to find what is this PM, right? Once I can find what is PM, that distance is only okay, fine. So how will you do? Can you find this length? You have to use this. So AM is actually projection of AP on this line, this line, this line, right? This line means this factor. In factor form, you can write. So I can write like this, right? So I can get AM from here, fine. Then I can find this distance. I can easily find. Acha, projection of AM is nothing but the projection of this factor AP on AM. AP कैसे निकलेगा? How AP will be done? AP can be also found because you know the points. AP means 2 minus 5, that is 7 I cap. Then 4, this is 7 J cap. And then minus 7 K cap. इसका projection इसके ऊपर. Can you recall that if you need to find the projection, you have to find the dot product. And then you have to divide by the magnitude of that vector on which the projection is needed. So magnitude of this is 1 plus 16 plus 81. So you get this length. You can find by using the distance formula this length. So now just apply Pythagoras theorem to find PM. This is a very interesting method. Very interesting method. Recently only I found. But otherwise we used to do by general method by finding the foot and then simply finding the difference. Both are equally correct, right? Anyway, next. We are now coming to the closure of the session. Around 5 or more, 7 problems are there. Maybe some are repetitive. So we'll be able to finish it within maybe half an hour next. So that the line passing through the points 1, A and B intersect the line joining these 2 points. What do you think? Is that a big problem? It's not a big problem in the sense of concept, but it's a big problem in the sense of length. Q, because you have to first find the equation of the line through these points. You will be ready with a line. You find the equation of the line through the points C and D. You will be ready with the another line. Then these two lines, they will intersect at a point. You find that point. So they are asking you to find that point only, right? So that, or else, if you don't find the point of intersection, you find their shortest distance. If the shortest distance is zero, you can comment that the lines are intersecting. And if the shortest distance is not zero, you can again comment that they are not intersecting. So in both way you can do it, but this is easy problem, but time taking problem if you don't practice. Find the value of lambda if the following lines are perpendicular to each other. Right? So many times we have done this kind of problem. So I think it's wastage of time to repeat, but you please do practice. Here it is minus, of course. Okay. Determine if the lines this and this intersect each other or not. Again, the same thing. Find the shortest distance. Find the shortest distance. If the shortest distance is non-zero, they are not intersecting. And if the shortest distance is zero, they are intersecting. And if addition to that, they might ask you to find the point of intersection as well, which I already discussed. Find the point on this line at a distance of 2 root 2 units from this point. See, this is a repetitive problem. Already we have done problems of this kind. So this will be a good problem for your practice once you see that particular question. This is a very important problem again, I'm saying. Find the foot of the perpendicular. Okay, again a repetition, right? Actually, I did not really screen the problems. Whatever problems I got, I have all taken from the question papers, PYQs from 2024 and 25 directly. My idea is that whatever problems are repeating, I mean, conceptually repeating, I will be leaving for you so that you can do adequate practice and board तक आपका practice हो जाएगा, right? Next, find the distance of this point from the point of intersection of this. See, again, this is a good problem. Why I am saying good problem? Acha, these are minus signs. These are minus signs. While removing the background, these are lost. Uh, this is also integrated problem because first you have to find the point of intersection. For that, you need to have the concept of a point on a line. Then you have to use the distance formula, class 11. Um, no, not distance formula. That solution, linear equations. Then you get the point. Then at last you have to find the distance formula. So this is an integrated problem, right? Please do that. Find the equation of a line in vector and Cartesian form which passes through this point and perpendicular to these lines and this line. Exactly same problem we discussed just before few slides, right? Passing through this point and perpendicular to both of these lines. So you can consider, you can start considering the line as x minus 1 divided by a, y minus 2 divided by b, and z plus 4 divided by c. And then you can apply the conditions of perpendicularity with them, or maybe you can use the cross product, right? Because this line is perpendicular to parallel to the vector with these components. This line is parallel to the vector with these components. So when you take the cross product of the vectors with this and these components, you will be getting a third vector which is perpendicular to both of this. So your required line will have that as the parallel line. So that way also you can find. Okay. Okay, this is the last problem, and this is a case study problem. I in last 2025 and 24, I found only one case study problem of three-dimensional geometry. So this is what I brought for you. Let us see. An engineer is designing a new metro rail network in a city. Initially, two metro lines, line A and line B, each consisting of multiple stations are designed. Fine. track for line A is represented by this, while track for line B is represented by this. Based on the above information, answer the following question. Find whether these two metro tracks are parallel. How do you check parallel lines? Ratios of the B vectors are to be same, or you can say B vectors are parallel. That means you have to just check whether these direction ratios are proportional or not. So 3 by 2, orally only you can check it. 3 by 2 and then it is minus 2 by 1. They are not equal. So they are not proportional. That means these tracks are not parallel. Fine. The first question is done. Okay. Next question. Solar panels are to be installed on the rooftop of the metro station. Determine the equation of the line representing the placement of the solar panels on the rooftop of line A station, given that panels are to be positions parallel to the line A's track and pass through the point this. So what they are asking, our solar panel should be fixed at the top of the roof, which is parallel to the track, but at a particular point it is to be passed. So they are indirectly asking what? Suppose this is the track and this is the point through which our solar track arrangement should pass, solar panel should be passing through. So this is the line equation they are asking you to do. It is at the rooftop. Suppose this there is a roof here and this is a track. This is the track. Over there is a roof. Below these trains are running, and here you are going to place the solar plates passing through this point, and this line should be parallel. Very easy. This point is there. As these lines are parallel, you can use the direction ratios of this line for this. Good question. Next, to connect the stations, a pedestrian pathway perpendicular to two metro lines is to be constructed. Please try to read it very carefully because this is the important concept. You have to construct a pedestrian pathway which is perpendicular to both the metros, which passes through the point this. Determine the equation of this pedestrian walkway. So, perpendicular to the two. What do you think? What they're asking? Actually, they're asking you to find one equation of a line passing through the point 3, 2, 1 and perpendicular to both these given lines. We have done this problem before. So I'm just feeling very good because that same problem has been manifested or represented in such a better way which normally you may not think about, right? So it's a very very good problem. So ये problem हमने किया है, so I don't want to again do it. So please try to involve this concept and do these problems. This is only one case study problem I got. It is the last part. An engineer is designing a new metro. This is already read. What is the last? Find the shortest distance between the line A and B. See, basically shortest distance marks are only 2 marks. But individually, when these problems are coming, at least 3 marks are given. So that way it is beneficial. Here it is loss. So I think I don't have any more problem for this. But before I sign off, I would like to just give you a message. Today I have collected 46 different problems only from the year 2024 and 25. And I have personally noticed that the varieties of the problems are less in numbers. Only idea is that whatever your core concepts are there, two, three concepts. One, equation of the lines, there are two forms. Another, shortest distance between two skew lines. distance between two parallel lines, and image of a point in a line, and foot of a perpendicular from a line, from a point to a line. So these are the basic concepts they have covered, and they framed many different problems, right? So this is my utter request to you. In 3D, very less thing is there to study. What you need to do nowadays, just go on rigorously practice. And I have prepared this material. I'll say that this is material only because 46 problem is not a joke. If you really do these problems, I'm very sure that you are not going to miss any single mark from 3D. Right? So with this note, signing off. And then of course I'll continue taking these classes, whether viewers are not there or not. I'm not really bothering about that. So as per my interest, I'll definitely conduct the classes on the other chapters as well. So have a good night. Thank you. I'm signing off.